All right, Matt 2, here we go. We got lesson 11.1.3, ratios of similarity. To honor Benjamin Franklin, designers will place a statue of him outside the entrance to the Liberty Bell Exhibit Hall in Philadelphia. Designers decided to place a smaller, similar version on a table inside the building. The dimensions of the life-size statue will be 4 times those of the smaller statue. All right, so we're looking at a scale factor, a linear scale factor of 4. All right, so next part. The planners expect to need 1.5 pints of paint to coat the small statue. Now that's going around the outside. So the small statue needs 1.5 pints of paint. And that's going on the outside, so that represents the area. And they also know that the small statue will weigh 14 pounds. So we know that it's going to be 14 pounds. And that's representing the materials that's making up the statue. So that's representing the volume. How many gallons of paint are needed to paint the life-size statue? All right, so we've got a scale factor of 4, which means the area should have a scale factor of 16, because area is in units squared, so it's the square of the scale factor. However, volume is in units cubed, so we should cube 4, and the volumes would have a scale factor of 64 instead. So for the paint, we're talking about the paint's covering the outside, so that represents area. So if we're comparing the life-sized model to the smaller model, the ratio of these two should be, looking at the area, 16 over 1. Now we know that the small one has 1.5 pints of paint. And we don't know how much the life-size one would have. So now we've got a ratio here. The ratio of the areas is 16 to 1. And then the ratio of the paint that we need would be x over 1.5. Doing cross products, we would get x is equal to 24. So we would need 24 pints of paint for the large statue, whereas we would only need 1.5 pints for the smaller one. If the small statue is made of the same material as a large statue, how much will the life-size statue weigh? So weight is based on how much material is in there, so how much volume of that material is there. So the life size compared to the small, looking at our volumes, would be 64 over 1. And we know that the small one had 14 pounds. And we don't know how much is in the life size. So if we do cross products here, we get x is equal to 896. So the life size one would be 896 pounds. The original small one is only 14, but the life size one has 64 times more volume. The Blackbird Oil Company is considering the purchase of 20 new oil storage tanks. They can buy jumbo storage tanks or standard models. Each standard model holds 12,000 gallons. Now that's the volume that we're talking about there. Its dimensions are 4/5 the size of the similarly shaped jumbo. So when we get a fraction like this, 4/5, the standard compared to the jumbo, standard is the smaller one, jumbo is the bigger one. So we can just say the ratio is 4 over 5. You could also, change this into like 0.8 over 1 if you wanted to, but we're just going to stick with what we've got there. So there we've got the standard to the jumbo, 4 over 5. Now that is the ratio of the sides, because we're talking about the dimensions. So the areas, if we're looking at the areas, they would be 16 over 25. for the area. Whereas the volume, remember, is the cube of the scale factor. So 4 to the third power is 64, 5 to the third power is 125. So the ratio of the volumes would be 64 to 125. First question, how much more storage capacity would 20 jumbo models give the Blackbird oil over the standard models? Okay, so let's start off, standard over jumbo, talking about the volumes. We've got 64 over 125. We know that the standard model has 12,000 gallons in it, and we don't know how much the jumbo model has, so we'll do cross products here. We get 64x equals 125 times 12,000, 1,500,000. And then we divide by 64, and we end up with 23,437.5 gallons. All right, that's not our answer. So this is saying how much more storage capacity would 20 jumbo models give the Blackbird over the standard, Blackbird oil over the standard. So we want 20, and I want the difference between the jumbo and the standard. So the jumbo is 23,437.5. The difference between those two models, if I subtract out the standard model, one single storage tank, the difference between one storage tank would be here. So that would be 11,437.5. That's the difference between one, and we want the difference between 20 of them. So 20 times that comes out to 228,750 gallons. If a jumbo tank costs 50% more than the standard tanks, which is a better buy? We don't need to know how much they cost because we can look at how much volume that they will hold. The jumbo is 125 compared to 64. If I take 125 and divide by 64, the jumbo is approximately 1.953125 times bigger. Now, if we're looking at that in terms of percentage, the 1 represents 100%. So 100% would mean that they're equal to each other. But this is 0.95 more, or 95% more. So the jumbo model actually has a volume that's 95% greater than the standard model. Now, the difference in cost is 50%. Well, the jumbo is 95% bigger. So this is a better buy. The jumbo tank is a better buy because we get 95% more volume for only 50% more cost. So the jumbo tank is a better buy. One cubic foot is approximately 7.48 gallons. What's the volume of the standard model storage tank in cubic feet? Standard was 12,000 gallons. And 1 cubic foot is 7.48 gallons. So when we do the conversion, 1 cubic foot compared to 7.48 gallons. The gallons in this conversion delete each other, they cancel each other out, the units cancel, and now I'm left with 12,000 cubic feet over 7.48. The gallons have gone away, and if I take out my calculator, comes out to approximately 1604 feet cubed. 1 meter is approximately 3.28 feet. How many cubic meters does the standard have? So we know that we have cubic feet. And it says that 1 meter is 3.28 feet. Now, this conversion is not enough as we have it written down because feet cubed and feet to the first power, we're only reducing one of the feet. These feet would not go away. So I'd have to multiply by another meter over 3.28 feet. Now I have feet squared, but this is feet to the third power. So I need another one. Now I've got feet times feet times feet. That's feet to the third power. So that will finally reduce the feet cubed up there. And now in my numerator, I have meters times meters times meters, which is meters cubed, which is what I wanted. I wanted cubic meters. Okay, so I'm just going to do 1604 divided by 3.28, divided by 3.28 again, divided by 3.28 again. And we get approximately, I don't know, about 45.5 meters cubed. All right, last problem. Rosalane is ordering wood chips to cover her dog run area. The size of the dog run is 9.5 feet by 12 feet. And she wants the chips to be 4 inches deep. Now 4 inches, 4 out of 12, that's 1/3. So we want it to be 1/3 of a foot deep. All right, so she calculates that she needs, the wood chips are only sold by the cubic yard. This is real. This happens in real life. If you want to get wood chips, for your flower beds or whatever, they always sell them by the cubic yard. So you'll go out, of course, and measure the area that you need in feet. And so then you have to convert it to cubic yards. Now, the people at landscaping supply stores are really used to people not knowing how to do this conversion, so they'll be really shocked if you can do this. It's happened to me before. They didn't believe that I calculated it correctly, and then I gave them all the numbers, and they're like, oh, you did do it. I'm like, yeah, I teach math. I can do this. Anyways, Rosalind calculates that she needs 12 cubic yards of wood chips, but she calls to place the order, and they're like, you know what? That's going to take an entire dump truck. And she only needs this small section, so she probably doesn't need a dump truck to cover this. She probably made an error. Let's see how many cubic yards she actually needed. So volume, we would do 12 times 9.5, that's the base area, and then times the height of 1/3 of a foot. So do 12 times 9.5 and then divide by 3. So 12 times 9.5 divided, what did I do? 12 times 9.5 divided by 3. She needs approximately 38 feet cubed. That's how much she needs. Now, what she probably did is she's like, well, there's 3 feet in a yard, so I'm just going to divide this by 3. That's how she's getting the 12. But that's not how it works. If you've got 38 feet cubed and you want to convert this into cubic yards, 1 yard equals 3 feet. But that doesn't cancel out the feet. We still have to multiply by another yard over 3 feet, and then another yard over 3 feet. Now, feet times feet times feet, that's feet to the third power, that reduces it. And we end up with 38 feet, yards cubed, because yards times yards times yards, over 3 times 3 times 3 is 27. So 38 divided by 27 comes out to she only needed 1.4 cubic yards. So she almost ordered like, I don't know, 9 times too much. So she should probably, they only sell in cubic yards, so she probably needs 2 cubic yards. She'll just have to make it a little bit deeper or spread it out somewhere else. So there. There you go, math. This is actually stuff that you could use in real life. I've actually used this before myself a couple times. All right, math hard. See you guys later. Bye-bye.